Welcome back, guys. It's Ms. Gumby. Today we're going to talk about proving triangles on the coordinate plane and talking about whether a triangle is scalene with no sides congruent, isosceles with only two sides congruent, or equilateral with all three sides congruent, and if it's also maybe a right triangle, has a right angle in it. Before we get going with that, let's look at our warm-up today. I've already graphed the vertices for ABCD, which is just a quadrilateral. All I know is it's got four sides at this point. So the first step was to graph this. Now I want to compare my slopes, and I'm just going to count these off of the graph. Just going to count my rise and my run. For CB, I'm going to count my rise and my run. I come up with 4 over 3. I'm going to now go to the opposite side. For DA, count my rise and my run. So I'm interested to see if the opposite sides have the same slope. Those have the same slope. Now let me look at BA. I fall 3 and then I run 4. And it's the opposite side of CD where I fall 3, run 4. It wouldn't matter if I did CD first and then did BA. Those have the same slope. So I have two sets of opposite sides that are parallel because they have the same slope. So therefore ABCD is a parallelogram. Now remember, our symbol for parallel is just two little parallel lines, and my shorthand for parallelogram is parallelogram. That's just my specific little shorthand. So now I know I've got a parallelogram. Let's get specific. I'm going to do some observations. I noticed that 4/3 and -3/4 are opposite signs. One's positive, one's negative, and they are reciprocals, meaning that they're flipped fractions, so they're perpendicular, so they form a right angle. Now I know I've got a parallelogram with at least one right angle. So I have to determine, is it a square or is it a rectangle? To do that, I need to look at the lengths of the sides. So I'm first going to find the distance of CB. I've got my side lengths of the triangle up here. I'm going to use those. The slope forms the triangle, the right triangle. Use those side lengths like we've been doing. So I know it's 5 units. Well, I know DA is going to have the same because it has the same side lengths there. So that's 5 units. Well, when I look at BA, it's a -3 and a +4. So -3 squared is going to be 9. +4 squared is 16. So it is 5 units. And I know that CD, that has the same slope values, it's also 5 units. Well, we don't use slope to determine that they are congruent. We use distance formula, but we put the slope numbers in the distance formula. Now I can see that all 4 sides are congruent. All right, now I know ABCD is a square because it is a parallelogram with at least one right angle and all sides are congruent. Okay, so now we're going to look at proofs with triangles. I've already plotted my points for A, B, and C, and I need to prove that it is an isosceles triangle, which means only 2 sides are congruent. So I have to do the distance of all 3 sides and compare it, because if all 3 sides are congruent, I have an equilateral triangle. Every equilateral triangle is an isosceles triangle, but not every isosceles is an equilateral. Think about that for a minute. All right, so I'm going to get busy on finding the distance of my sides. Now I'm going to use my slopes. Okay, so for BA, I drop 2 and I run 5. That's my 5, my slope, and I'm going to use those numbers in my distance formula. So I know that the length of BA is square root of 29 units. Now for CA, I'm going to rise 5. think I've got my C in the wrong spot, or either my A. Got A in the wrong spot. Need to move that over. Goes here. So that's just going to move my little lines over. Let's do it like that. Okay, so let's get back to that slope for CA. Now I'm going to rise 5 and run 2. The slope for BA is correct, 2 and 5. I'm going to put these slope numbers into my distance formula. And I find out that it is also root 29 units. So I know BA is congruent to CA. So BA and CA are congruent. I've given them some matching notation. This is my A point out here. All right, I do have to still do the distance of the third side to make sure that it's not an equilateral. So when I calculate my slope for BC, I drop 7 and I run 3. So I find out that it is root 58 units. BC is not congruent to either BA or CA. So ABC is an isosceles triangle because it has only 2 sides that are congruent. Now guys, before we move on, let's notice this. See how those slopes are opposite sides and reciprocals? That tells me I got a right angle right there. So that makes this also a right triangle. Just FYI. No, the question didn't ask us that, but just an observation. Let's do another one. So now I have to prove or disprove that the triangle, which is already plotted for us, RST, is an equilateral triangle. Well, what I've done here is I've counted off the slopes for each side. I've already got those counted off. So now looking at RS, I've got to find my distance of RS. And it is root 45 units. Okay, ST. This is ST. I've got and it is going to be the root 90. And I'm not simplifying right now because I'm just using this for comparison. Then RT, I've got a negative 3 and a positive 6. So this one is also root 45 units. So I know this one and this one are congruent. And the third ST is not congruent to those. All 3 sides are not congruent. So ABC is not an equilateral triangle. It only 2 sides are congruent, which makes it isosceles. Again, the question only asked us to prove whether it was equilateral or not, but I'm just wanting to make those observations. It says now look at the triangle and let's prove or disprove that it is a right angle. So when I look at the slopes, when I'm looking at RS, it is 6/3. When I look at RT, it's a negative 3/6. Those are opposite signs. One's positive, one's negative, and they are reciprocals, meaning that they are flipped. Therefore, they are perpendicular and form a right angle. So I know I've got a right angle here. Triangle RST is a right triangle because it contains a right angle formed by sides RS and RT. Moving on to the next one. Determine what type of triangle is formed. So first thing I want to do is I want to look at those slopes. So I'm going to look at my slope for BA. I count up 6 and a run of 4. When I look at BC, I'm looking that I drop 2 and I run 3. Let me think about this. This simplifies to 3 halves. So when I compare these 3 halves and a negative 2/3, I can see that those two lines are perpendicular. So I've got perpendicular slopes here, which equals a right angle. So no, BA and BC form a right angle. Okay, my slope of CA, I count rise of 8, a run of 1. Okay, so I know that it's a right triangle, but I have to see, is it isosceles, equilateral, or scalene? So I'm going to put each of these slopes into my distance formula. So for BA, I'm putting in the 6 and the 4. I am not going to use the reduced slope for distance. If I do that, I'm changing the lengths of the right triangle that I draw to find the hypotenuse. I don't want to do that. I'm not going to use the reduced slope. And this is square root of 15, which reduces to 13. Okay, for BC, I've got a negative 2 and 3. It's root 13 units. And for CA, I have an 8 and a 1. So when I compare these to root 13, just root 13, and root 65, I have no sides congruent. So ABC is a scalene right triangle. No sides congruent, but does contain a right angle. Okay, let's do one last example today together. Identify the type of triangle, scalene, isosceles, or equilateral, or right, or combination with these vertices. It's already been plotted for us, so we're going to start with the same thing. I'm going to start looking at my slopes. I'm looking at the slope of AB. I rise 1 and I run 3. To find the distance between those 2 points, I'm going to use those slope numbers in my distance formula. 1 squared is 1. I know the distance is root 10 units. Okay, I'm going to look at B. I drop 3 and I run 1. Put those slope values into my distance formula. I find out that, okay, AB and BC are congruent. They have the same length. But also, I notice that their slopes are opposites. One's positive, one's negative, and they're reciprocals. So they're also perpendicular. So that I know AB is congruent to BC, and I know these form a right angle. All right, so now I just got to look at AC. I compare the slope here. I drop 2, and I run 4. I'm going to keep those original slope values for my distance. My slope here is a negative 1/2. But for distance, I keep the non-simplified lengths. Square root of 20, and that simplifies to 2 root 5 units. So AC is not congruent to AB or BC. It's also not perpendicular. So I know that ABC is an isosceles, has 2 sides congruent, and it's also a right. It is an isosceles right triangle because it has a set of perpendicular sides. All right, guys. Those are all the examples I have today for trying to identify the type of a triangle, scalene, isosceles, equilateral, and or right on the coordinate plane. Hope you have a great day, and I will talk with you soon. Bye.